Good afternoon. What I'm going to do today is I'm going to explain how to solve both of these problems. And these are your notes on solving exponential equations. As you can see to the left hand, we have 8 to the power x is equal to 2 to the power x plus 6. That is an example of an exponential equation. And then to the right, we have 5 to the power x minus 2 is equal to 200. What I'm going to do is I'm going to go ahead and scroll down. And as you can see on this assignment, there is a URL. So we're going to go ahead and follow that. I'm going to double click. And it's going to open up. So just give me a minute. Okay, so this screen will appear, and as you can see, the problem is here by step, and I want to bring your attention to the second step, in which we're going to go ahead and apply the logarithm of base 2 to both sides, and you want to use the smallest base if possible. And when you have the inverse property, as you can see, we have the inverse property. What you can do is now you can bring down the exponent. You have x plus 6, and you have equals to the log of base 2 of 8 to the x. And then what you can do, since you want to use the inverse property again, you can bring down the x, and you have x times log of base 2 of 8 is equal to x plus 6. And as you can see, what they did on the next step is they went ahead and changed the base. And when there isn't a base here, by default, that is a base 10. So what you can do is you can use the calculator, and you can calculate log of 8 divided by log of 2. And you will get 3 when you place it into the calculator, which is a product of 3 times x, which is equal to x plus 6. And then you can subtract x from both sides, and you're left with 2x equals 6, and then you divide it so x is equal to 3. The second problem, it's very similar. You have 5 raised to the x minus 2 is equal to 200. And once again, we do know that our lowest base is 5. So we're going to go ahead and apply log of 5, log of base 5, and then we have 5 raised to the x minus 2. And then we're going to also do it to the right side. We have log of base 5 of 200. Because of the inverse property, we can go ahead and bring down the exponent, which is going to be x minus 2 is equal to log base 5 of 200. And as you can see on the next step, what they did is they went ahead and they changed the base and made this into base 10. So the 200 is in the numerator and the 5 is the denominator, and we get the log of both, which gives us the common base of 10. And you can do that in the calculator. You're left with x minus 2 is equal to 3.29. You add 2 to both sides, and so we have the value of x is equal to 5.29. Once again, there were several places when we used the inverse property. And on step 3, we use the inverse property. On step 4, we use the change in base property. And then we evaluate it, and then that was the value of x. I'm going to go ahead and go to the next screen. And it's very similar once again. We have 7 raised to the power negative x is equal to 21. So we're going to get the lowest base, which is 7, and we're going to apply the log of base 7 to both sides, as you can see that. With that in mind, on the next step, you can use the inverse property here to bring down the negative x. Remember, just like our last problem, we had the log of base 7 of 21. We had something similar in the last problem, so we can change the base. And the base that we're going to be using, once again, is 10, because that's what you're going to use in the calculator. And when you figure this out in the calculator, you have negative x is equal to 1.56 divided by negative 1, and you have x is equal to negative x. You have x is equal to negative 1.56.